So the lab we're about to go into is the Kleinschmidt Hydraulics Lab. And Kleinschmidt Associates is a Maine-based engineering firm, again, a few miles down the road from us here in Orono, what I like to call the second largest homegrown engineering firm in Maine. I mentioned downstairs a while ago there are two materials you cannot escape as a civil engineer. One is concrete, the other is water. This is a lab where we play with water. It's our required third-year course in fluid mechanics. It's called hydraulics, basically fluid mechanics for civil engineers. A 3-credit course where you learn the theory and the mechanics behind it, and a 2-hour lab every week where you go in and you actually play with water and see how the theory pans out in a real environment. So let's go in and see what they're doing. There's a lab going on right now. Guys. So we've got a bunch of students in here actually doing the weekly lab, and we've got Lauren Ross. She's a faculty member in our department, an assistant professor. She teaches the class in hydraulics. Neil Fisher over there. Neil is our lab manager, but he really spends a lot of time as an instructor, and he actually teaches the lab. Taylor, I assume you're in here helping today, right?
Yes, I'm the laboratory TA.
Yeah, so Taylor's a grad student and an alum of our undergrad program, and she's a TA helping out. At this point, I'm going to turn it over to Lauren and let her talk about exactly what's going on in here and why we care about hydraulics.
All right. So hi, everyone. Welcome to the Hydraulics Lab. So in this lab, the students get the hands-on portion to the hydraulics class that is required for all civil engineering students. Students typically take this the fall semester of their junior year, and this class is a gateway to taking other required classes or upper level elective classes, in the civil engineering focus area of water resources. So those classes include hydrology, groundwater hydrology, and open channel hydraulics. And in this class, students learn the basics of fluid statics, so that's understanding fluids at rest, and also fluid kinematics, so that's understanding fluids in motion. And so as Bill mentioned, I teach the lecture portion of the class, and Dr. Neil Fisher teaches the laboratory portion. And so let's go and see if they can tell us a little bit about their experiment that they're doing today.
Okay, so what the students are working on today is an introductory to pipe flow, and they're trying to look at the volume flow rate through a pipe and comparing that to the velocity through a changing pipe section and how that relates to changes in pressure as a function of energy through the system. So they're working on their first flow rate right now, and they basically work in groups to collect their data, and then they'll take that home and write it up as a formal report as part of their learning experience. Okay. Yeah.
Great. So Taylor Bailey's the teaching assistant, so I'll let her say a couple of words.
Yeah, hi guys. I'm a PhD student in civil engineering. I'm focusing on water resources and coastal engineering. So I like to come to the lab to help out. It's a good experience for me to work with Neil, and it's also a lot of fun.
Yeah, so that would be great. We can get a little bit closer. Oops, sorry. So the students are measuring changes in velocity and pressure through what's called a Venturi meter. So if you get close to it, you can see that there are changes in the diameter of this pipe. We can measure how the pressure is changing using these what are called piezometers up at the top to measure changes in water level. So this is just one of the experiments that we do in the hydraulics lab. So just to tell you about some other experiments that we do, we also do experiments on quantifying fluid forces on submerged surfaces. So this has direct applications for dams and also seawalls. We do experiments with buoyancy and flotation in this lab. We measure flow and transport through pipes, and students are then able to size pumps and pipes for designing simple pipe systems. And you can see in the back we have the hydraulic flume back here. So this will allow us to do open channel hydraulics experiments. For example, we measure subcritical and supercritical flows, and that gives us an idea of erosion and scour that will happen in natural channels. So that's some of the experiments that we do.